Hello everyone, hope you're all doing great. So today we're going to go through Edexcel International Paper Math 2 full revision guide, covering all the 8 chapters, and hopefully we have a really great exam tomorrow. I'm going to also tell you which formulas are already in the data booklet and which ones we should memorize, and also make sure to watch this video twice the speed and do as many past papers as possible. Learn how the markers would like you to answer, and basically for the questions that you don't get, either watch YouTube videos or memorize the mark scheme. There's a trend, so in every past paper there must be a question of each chapter, so make sure you're familiarized with every question. Let's dive in without further ado. So first of all, we have simplifying algebraic functions. So basically you factorize the numerator plus the denominator and then cancel the common factors to make it simplified. Use the long division to divide polynomials by x plus p or x minus p, where p is any constant. So long division is like this. You take your divisor, you divide basically the same exact way that we learned division, and then if you have a remainder of 0, then that's a factor, and if not, then it's not a factor, so you just add it to the end part. So as you can see here is plus 18, so this times this plus the 18 and would give you the actual number. Anyways, factor theorem states that f of x is a polynomial. So if f of p is 0, then fx minus p is a factor. If f of minus xp is a factor, then fp is 0. We need to be comfortable moving back and forth with this. If f of b over a is 0, then you times the x by a and minus the b. So ax minus b is a factor. The remainder theorem basically says that if f of x is divided by ax minus b, then the remainder must be this. So again, make sure that you could go from here to here, and you know that you should add and then multiply to get that polynomial. Proof mathematical statement is to use deduction. Start from the known facts, the known definitions, then use your logical steps to reach the final conclusion the question wants you to get to. In proof, you must state facts and assumptions used. You must show every step of your walking. You must follow logically each step from another. Cover all possible cases, meaning plus, minus, odd numbers, even numbers, and write a statement of proof when you're done. To prove identity, you might start expression on one side to get to the other one. So basically you manipulate until you get something that's equals to the other side, and you must show every step to get full marks. Proof mathematical statement is true by exhaustion. So this is breaking it into smaller cases or sections, and then proving each case separately. So this is the one that usually has higher marks and takes more time, so make sure you're good with that. Proof mathematical statement is wrong. By counterexample, you only need one example, and that example must be wrong. So basically, if 2x is always an odd number, you should say like if x was 1.5, it gives you 3. So it doesn't apply to all numbers. So chapter 2, if you have a midpoint, you want the distance of both of them over 2. So x1 plus x2 over 2 gives you the x coordinates. y2 plus y1 over 2 gives you your y coordinates. Midpoint is basically what's exactly in the center, and we want the coordinates. Perpendicular bisector is basically perpendicular and passes through the midpoint. So if you have a line AB here, you want to pass it at 90 degrees, and you might need to pass it exactly at the center. So gradient is -1 over m because it's perpendicular, and passing to the midpoint means it has the coordinates of them added together over 2. You could also construct this using circles. Equation of a circle with center 0, 0 is x squared plus y squared, giving you r squared, where r is your radians. is your radius. Equation of circle with center AB, x minus a squared plus y minus b squared is going to give you your radius squared. Straight lines coincide or intersect with circles in different ways. They could not intersect at all. They could intersect once or twice. You could set it equal to each other and use b squared minus 4ac to see how much they intersect. So tangents are perpendicular to the radius at given intersections. Tangent only touches at one single point. Perpendicular bisector of a chord will go through the center. As you could see here, if we have a chord which is any 2 points on a circle, you have a perpendicular bisector, it must go through the center. If you have ABC, the triangle here, and B is 90 degrees, then your circle must be on the diameter, meaning AC is the diameter of the circle. Angle in semicircles are always 90 degrees, so it doesn't matter if it's here, it's always 90. Find center of a circle given 3 points on the circle. So basically you find the equations of the perpendicular bisectors. So the equation of this and then the equation of this. And then you set them equal to each other to find the points of intersection, being the coordinates of your center of your circle. So chapter 3 says basically logarithms. So if you have log of n equals x, then a to the power x is 9n, where a should not be 1. So laws of logs. So if you have log of ax plus log of ay, it's a multiplication law. So you say log of axy, and then same thing for subtraction, you only divide. And then if you have log of ax to the power of k, you bring the k to the front, meaning k log ax. Recognize these special cases. So if you have log of 1 over x, it's basically log of x to the power minus 1, which you could again bring this power here, so negative log ax. So this only applies when k is negative 1. Log of a is always 1, so any number to the power of 1 is always that number. Like if you have 8 to the power of 1 is always 8, 1200 to the power of 1 is always 1200. Log of a to the power of 1 is always 0, because any number to the power of 0 is 1. Changing the basis. So if you have log ax, then that means log bx over log ba is that. And then log ab equals log 1 over log ba. So Pascal's triangle. So basically you add adjacent pairs to get to the lower number. As you can see here, and everywhere. So n plus 1 row on Pascal's triangle would give you a coefficient of a plus b to the power of n. This is binomial expansion. Use factorization notation to find entities of Pascal's triangle easily. So that's when we use our NCR on our calculator, or this formula. Let me just check if this is on. Yes, this and the binomial series expansion is both on our data booklet, so you don't need to memorize it, just familiarize yourself with it. This is an NCR button we use on our calculators. Make sure you know where it is and you're comfortable using it. Again, this is given in the data booklet, and it's only valid for x's between -1 and 1. So basically you factorize if necessary, then substitute n and x, getting it from your calculator, and x each time is going to add to its powers, and then you simplify each term and then write the values. No, if x is so small, then the first few terms of binomial expansion can be used to find approximate value. So if it said approximately find out this, then you know that x must be a small number. Arithmetic sequence is basically constant difference. So you're adding or subtracting something. The nth term is given by a plus n minus 1 times d. This is given in your data booklet. Sum of terms, meaning adding all the terms, is n over 2 times 2a plus n minus d. This is given in the data booklet. And also this one, which is basically your last term plus your first term times n over 2, n being the term you want to find. Geometric sequence means you have a common ratio, so multiplying or division. The formula is a times r to the power of n minus 1. Sum of the first n terms is going to be Sn is either a times 1 minus rn over 1 minus r, where r is not 1, or the opposite way around, where this comes here. So rn minus 1, and again r minus 1. Geometric sequence is convergent only if the magnitude of your r or your difference is smaller than 1. Then you could find the sum to infinity. Again, this is given in the data booklet, and it's a over 1 minus r. This is the sigma notation, so it shows you sum or like adding everything together. You write limits on top or the bottom to show which term you're summarizing. A sequence is increasing if the un plus 1 is bigger than the un, so your next term is bigger than your previous term. So if I have like 1, 2, this is bigger, so this is increasing, and the opposite thing goes for decreasing. So 2, 1 is decreasing because my first term is smaller than my next term. Periodic means that it's repeating in a cycle. So if you have an integer like k, which we call order, we know that un plus k equals un, which is basically just this, and doesn't matter how many numbers you're going forward, it's always the same thing. So chapter 6. So for a point P is xy on a unit circle such as OP, the theta is that it makes with the positive axes is, so if you want cos theta, then it equals this x here, and the x coordinates are given. So if you get sine theta, you are going to get this y, and then you're going to get y coordinates of this p. And if you want tangent, then it's y over p, because it's sine over cosine. So you're going to get the gradient. This is also well known with SOHCAHTOA. And we know that sine over cos gives you tan. And you could always label your diagram to make sure you are doing the right thing. Use quadrants to determine trigonal ratios. So you're deciding if it's positive or negative. This is a quadrant. So basically you go from 90, 180, 270, 360. Same thing for the radians. So pi over 2 pi, 3 over 2 pi, and 2 pi. So here, so how we write this is basically draw any quadrant, say cast from the bottom right, and then here all of the sine, tan, and cosine are going to be positive. Only sine is going to be positive here, only tan is going to be positive here, and only cosine is going to be positive there. You could use these as well. So if you have sine of 180 minus theta, then you have positive sine because it's here. And then you do the same thing. Because it's 180, which is this line, because we know 180 is like half a page, then you know that this goes, we cast it, this goes in the sine quadrant, so therefore it's going to be sine positive and the other two negative. Same thing happens with these, so you know you're moving after this. So it's going to be 180 plus any theta you are calculating. And because it's in the t section, only tangent is going to be positive. Same thing happens with cosine, except it's 360 minus or 270 plus theta. So 360 minus, it means a full circle, but minus the theta that you want to calculate. And in this case, only your cast or cosine is going to be positive. So make sure you know these. So sine 30 is the same as sine pi over 6, which is a half. Sine 45 is a radical 2 over 2. Sine 60 is radical 3 over 2. Cos 30, note that these are the exact opposite. So cos 30 is radical 3 over 2. Cos 45 is the same, radical 2 over 2. And then cos 60 is half. Again, here, all you gotta do is memorize the tangent on one of these to get to the cos. So tangent of 30 is 1 over radical 3, tan of 45 is 1, tan of 60 is radical 3. If you have theta sine squared plus cosine sine squared equals 1. And you could also say theta sine squared plus cosine squared minus 1 is going to give you 0. For all values where cosine is not 0, because you do not want your denominator to be 0, you could have tan equals sine theta over cosine theta. Solutions of sine theta is k and cosine theta is k only exist when k is between -1 and 1, and this is because if we go back to the graphs of sine and cosine, you could see that the values are only true when we're going from -1 and 1. But for tangent, you can have any values. So basically your p is going to be anywhere on the graph. So we don't have any limitations. The principal value is the angle you get when you inverse a trigonometrical expression in your calculator. So if I have sine inverse and then I get x, that x is my principal value. Chapter 7. Function of f of x. If f prime of x is bigger than 0 or equals to 0, then it's increasing. If it's smaller or equals, it's decreasing. Why? Because if you have a positive gradient, that means your function is increasing. If you have a negative gradient, it's decreasing. And we know f prime of x is the gradient. So if you differentiate f of x twice, you get a second derivative. And that is d squared y and dx squared. Stationary points are when f prime of x or the gradient is 0. So basically when the gradient is 0, you could get 3 possible things: a maximum point, minimum point, or a point of inflation. If f of x has a stationary point when x equals a, if that gradient was more than 0, then it's a local minimum. If the gradient of the gradient, which is f prime of a, is less than 0, then it's a maximum, and if it's equals to 0, then it's a point of inflation, maximum point, or minimum point. And how you find difference is you look at the points on either side. So you look at the points after or the points below, and if it was increasing and decreasing, like if it's a point of inflation here, these are increasing, these are decreasing, so you can see it's a point of inflation. If it's a maximum point, both after this are going down, so it's going to be a maximum point. And if you have a minimum point, all the points after that are increasing, so you can find that it's a minimum point. So then we have this, which you basically limits your dx. So which is if you have f of x and then you want the difference between b and a, you do f of b minus f of a to get that difference. So area between a curve where x is a and x is b. So I have two lines and I want to find the area in between of them in that significant curve. I do limitation from b to a of the y dx, where y is my f of x and it is the equation of the curve. So if it's 3x minus 2 or 3x squared, it's the same thing. If below x-axis, you get a negative answer, so negative magnitude. More complicated areas use trapezium plus triangle. Trapezium rule is this, so it's half of the height plus the first y and your last y and the double of each y-intercept that you are going with. So if I have something like this, I want to limit it from here to here, then I do my first one plus my second one and every y in between of here. So I calculate every y in between, double it, and then use my trapezium rule, which is also given in the formula booklet. And then this only applies when h is b minus a over n, again given in the formula booklet. And then that's it. So make sure you watch this video at least a few times just to memorize and have everything on the back of your mind, and do as many papers as possible. Make sure you familiarize yourself with mark schemes, and good luck.